Hello students, welcome back to Standard 7 Mathematics Digital class. In the previous video, we learned how to divide indices having same base. Now, we are going to learn some rules of indices. We have learned if a is any rational number and mn are integers, then a raised to the power m multiplied by a raised to the power n becomes a raised to the power m plus n, and a raised to the power m divided by a raised to the power n becomes a raised to the power m minus n. Also, a naught equals to 1 and a raised to the power 1 is a. That is, the first power of any number is the number itself. Now consider another example, 4 by 5 raised to the power 3. In multiplication form can be written as 4 by 5 multiplied by 4 by 5 multiplied by 4 by 5. Now it can be shown as 4 multiplied by 4 multiplied by 4 upon 5 multiplied by 5 multiplied by 5. When fractions are in multiplication, then we can simply multiply the numerators and denominators. It is equal to 4 raised to the power 3. As 4 is multiplied by itself 3 times, so in index form it can be written as 4 raised to the power 3, as well as 5 multiplied by 5 multiplied by 5 can be written as 5 raised to the power 3 or 5 cube. Now consider another example, that is 3 multiplied by 5 raised to the power 2. It can be written as 3 multiplied by 5 multiplied by 3 multiplied by 5 2 times. As you can see, power is 2, so in multiplication form it can be written as 3 multiplied by 5 multiplied by 3 multiplied by 5. Now it is equal to, you can see 3 multiplied by 5 multiplied by 3 multiplied by 5. There is 3 2 times. 3 is multiplied by itself 2 times. So it can be written as 3 raised to the power 2 multiplied by 5 raised to the power 2. So we can conclude from these two examples that if a and b are non-zero rational numbers and m is an integer, then a multiplied by b raised to the power m equals to a raised to the power m multiplied by b raised to the power m, and a upon b raised to the power m is a raised to the power m upon b raised to the power m. This is one of the rules of indices. Now what is a raised to the power minus n? A is a rational number and m is its negative power. to the power minus m can be written as a raised to the power minus m multiplied by 1, as a raised to the power minus m multiplied by 1 is a raised to the power minus m only. Now, a raised to the power minus m multiplied by 1 can be written as a raised to the power minus m multiplied by a raised to the power m upon a raised to the power n. We have written 1 equal to a raised to the power m upon a raised to the power m, as in both the numerator and denominator there is same index form, that is a raised to the power m. They can be cancelled out and we get 1. Now, a raised to the power minus m multiplied by a raised to the power m upon a raised to the power m, you can see now these two index forms, that is a raised to the power minus m multiplied by a raised to the power m, are in multiplication. So, while multiplying indices having same base, that is a here, you can see in both the index form base is same, that is a. So, while multiplying such indices, we simply add the powers. So, a raised to the power minus m plus m upon a raised to the power m. We have added the exponents, so this becomes a raised to the power minus m plus n. Now, a raised to the power minus m plus m upon a raised to the power m equals to minus plus minus, and as you know, these two are negative and positive integers. So, same integers with opposite signs can be cancelled out and we get a raised to the power 0 or a naught upon a raised to the power n. We know a raised to the power 0 on a naught equals to 1 upon a raised to the power n. Denominator is same, that is a raised to the power m, and a naught can be written as 1. So, a raised to the power minus m can be written as 1 upon a raised to the power m, and this is another law. If m is equal to 1 in a raised to the power minus m, then a raised to the power minus m equal to 1 upon a raised to the power m becomes a raised to the power minus 1 equal to 1 upon a raised to the power 1. We have substituted m with 1 in this rule. Now, a raised to the power minus 1 equals to 1 upon a, as we know, a raised to the power 1 is the first power of a, and the first power of any number is the number itself. So, a raised to the power minus 1 becomes 1 upon a, and this is multiplicative inverse of a. where a is any rational number. For example, multiplicative inverse of 3 by 5 will be 5 by 3. That is reciprocal of 3 by 5. Now let us consider 4 by 5 raised to the power minus 2. If you can observe, this is in the form of a raised to the power minus m. As we have learned, a raised to the power minus m can be written as 1 upon a raised to the power n. So, it can be written as 1 upon 4 by 5 raised to the power 2. Now, simplifying this, it can be written as 1 upon 4 by 5 multiplied by 4 by 5. This is the multiplication form of 4 by 5 raised to the power 2. And this is equal to 1 upon 16 upon 25. We have simply multiplied the numerators and the denominators. Now, 1 upon 16 upon 25, it is in the form of division of two fractions. As you have learnt in your previous classes, while dividing two fractions, we simply multiply the first fraction, that is 1, or can be written as 1 by 1, by the reciprocal of second fraction, that is 16 upon 25. Its reciprocal is 25 by 16. I have simply multiplied the first fraction by the reciprocal of the second fraction. It becomes 25 by 16. Its index form is 5 by 4 raised to the power 2, as 25 can be written as 5 multiplied by 5 or 5 square, and 16 can be written as 4 multiplied by 4 or 4 square. Now, you can observe that 4 by 5 raised to the power minus 2 has become 5 by 4 raised to the power 2. So, we can conclude that if A and B are rational number, A is not equal to 0, B is not equal to 0, and M is an integer, then A upon B raised to the power minus M equals to B upon A raised to the power M. This is one of the rules of indices. Now, consider 3 raised to the power 2 raised to the power 3. You can see 3 raised to the power 2 is an index form, and 3 is the power of this index form. So, to solve this, consider 3 raised to the power 2 or 3 square as the base and 3 as the power of this complete index form. It can be shown as 3 raised to the power 2 multiplied by 3 raised to the power 2 multiplied by 3 raised to the power 2. This is the multiplication form of this index form, where 3 raised to the power 2 or 3 square is multiplied by itself 3 times. Now, simplifying all the 3 index forms or simplifying these indices. 3 square can be written as 3 multiplied by 3 multiplied by 3 multiplied by 3. Again, this 3 square can be written as 3 multiplied by 3. Now, what can we observe? That 3 is multiplied by itself 6 times. So, it can be written as 3 raised to the power 6 in index form. Now, consider another example, that is 3 by 5 raised to the power minus 3 raised to the power 2. You can see 3 by 5 raised to the power minus 3 is an index form and 2 is the power of this index form. Now, in multiplication form, it can be shown as 3 by 5 raised to the power minus 3 multiplied by 3 by 5 raised to the power minus 3. Now, you can see these two are the indices having same base. Base is 3 by 5. To multiply such indices, we simply add the exponents. So, 3 by 5 raised to the power minus 3 multiplied by 3 by 5 raised to the power minus 3 can be written as 3 by 5 raised to the power minus 3 plus minus 3. I have simply added the exponents. Now, 3 by 5 raised to the power minus 3 plus minus 3. Plus minus becomes minus. So, it is 3 by 5 raised to the power minus 3 minus 3. Now, simplifying it, 3 by 5 raised to the power minus 3 minus 3. As you know, minus minus is plus with negative sign. So, it becomes 3 by 5 raised to the power 6 with negative sign. Or we can write 3 by 5 raised to the power minus 3 raised to the power 2 equals to 3 by 5 raised to the power minus 6. Now, from these two examples, we can conclude that if a is a non-zero rational number, then a raised to the power m raised to the power n equals to a raised to the power m multiplied n or a raised to the power mn. This is another rule of indices. Now, revise all these rules. Thank you.